Welcome everybody to our business math course. Today we're doing the chain rule. This is Magda Talib Al Hinay from Sultan Qaboos University and I welcome you all to this video. Here we go. So the chain rule in fact is telling us how to differentiate the function of a function. Suppose we have y is a differentiable function of u and u is a differentiable function of x, then y is a differentiable function of x also. So we have the chain rule saying that dy by dx is equal to dy by du multiplied by du by dx. Let's see the following example. Differentiate y equals x squared plus 7x all cubed. We will rewrite this as in the form of y is equal to inside cubed. Now we differentiate, we put the 3 down and we reduce the exponent by 1. So we will have 3 times inside squared multiplied by derivative of inside with respect to x. So we will have 3 multiplied by x squared plus 7x, which is inside, all squared multiplied by derivative of inside, which is 2x plus 7. See the second example in this section. Here we have differentiate y is equal to 3x all over 2x plus 1 all squared. We're going to apply the chain rule and the quotient rule. So first of all, we have y prime is equal to 2 into 3x over 2x plus 1, yes, times derivative of inside times derivative of 3x over 2x plus 1 with respect to x. Here we apply the quotient rule. So next step we will write y prime is equal to 3 times 2 is 6. Here comes the 6x all over 2x plus 1. Inside this bracket we have denominator squared. Denominator times derivative of numerator minus numerator times derivative of denominator. This is the quotient rule. Now we simplify. 3 times 2 is 6. So here we have 6x and here we have minus 6x. These will add up to 0. So we are left with, this is the first bracket, the second bracket, 3 in the numerator and the denominator, we have the 2x plus 1 all squared. So we will have y prime equals 18x all over 2x plus 1 all power 3. Okay, now we come to a very interesting problem, which is an application of the chain rule. We have the quantity Q related to the number of employees through the relation Q is equal to 10m squared all over square root of m squared plus 19. We are asked to find the marginal revenue product when the number of employees is 9. The marginal revenue product is the change in revenue with respect to the employees. We are given the demand equation P is equal to 900 over Q plus 9. The marginal revenue product is the derivative of the revenue with respect to M. And we all know that revenue is related to Q through the relation R is equal to PQ. In order to find the derivative of the revenue with respect to M, we have to use the chain rule. So derivative of revenue with respect to M is equal to the derivative of the revenue with respect to Q multiplied by the derivative by the derivative of Q with respect to M. Okay, so now we will work on finding each of these and then evaluating the value of these two at m equals to 9. So first of all, we are going to work on finding dr by dq and then we will find dq by dm, evaluate them at 9 and m equals to 9, and then we multiply them to get whatever is required in this problem. So first of all, we have revenue is equal to price times quantity. There we go. And then we simplify to get 900 Q in the numerator, Q plus 9 in the denominator. To differentiate this, we use the quotient rule. Yes, denominator squared, and then up here, denominator times derivative of numerator, which is 900, minus numerator, which is 900 Q times derivative of denominator, which is 1. We can see that there are terms that will add up to 0, so we are left with 8100 over Q plus 9 all squared. This is the marginal revenue, the derivative of the revenue with respect to quantity. Next, we move on to find the derivative of the quantity with respect to the number of employees, which can be easily found from equation 1. Again, we use the quotient rule, denominator squared, denominator times derivative of numerator minus numerator times derivative of the denominator, which is a bracket power half. Apply the chain rule. We have half into the bracket power half minus 1, which is minus half into the derivative of what's inside the bracket, which is 2m. Now we cancel this 2 with the half. So we go and then we take also the m with the m squared, and we put them here to be m cubed. So here we have the d cubed by dm is equal to 20m square root of m squared plus 19 minus 10m cubed all over the denominator squared. So now, what else shall we do? We should say that we want to evaluate this at m equals to 9. This is easily done. But how can I evaluate this at m equals to 9 from equation 3 in front of us here? So I have to see what is q when m equals 9. This we do here. At m equals 9, I take the m and plug it here and get the corresponding q to be as you see in front of you. Q is 81. We move on. So now we want to find dr by dm at m equals to 9, or equivalently q equals to 81. From this equation number 3, we have that if I put 81 here, I get 81 plus 9 all squared, which is 8100. This is equal to 1. Next, I take what I found in equation 4 and I plug in the m to be 9. So I calculate the dq by dm to be 10.7. From the last 3 equations, we combine them all together to get dr by dm, the marginal revenue product at m equals 9, q equals 81, which is coming out to be 10.7. And this will be the end of this section for the marginal revenue product. Maybe we can take further more examples. Let's see what we'll do next. Let's see this example. We have differentiate y equals 3x plus 1 all power 5 multiplied by 2x plus 1 all power 4. We see the quotient rule, the product rule, and the chain rule together. So we start with the derivative. We will differentiate first the first bracket. So the derivative of this bracket, we all know that it is 5 times 3x plus 1 all power 4 multiplied by 3, the derivative of inside. So let's see how will we write this. Yes, there we go. This is 5, this is 3x plus 1 all power 4 multiplied by the derivative of inside multiplied by the second function as it is. And then here we put the first function 3x plus 1 all power 5 multiplied by the derivative of the second function. When we differentiate this bracket, we get the 4 down, we reduce the exponent by 1, so we will have 4 into 2x plus 1 all cubed multiplied by the derivative of inside, which is 2. Now we will write for the first term 15 into the bracket power 4 multiplied by 2x plus 1 all power 4. So we have 15 into 3x plus 1 power 4 into 2x plus 1 power 4 plus 8 into 3x plus 1 power 5 multiplied by 2x plus 1 all power 3. Now we will take this bracket 2x plus 1 all power 3 common factor, as well as 3x plus 1 power 4 also it will be taken as a common factor. So for the first term, we'll be left with 15 multiplied by 2x plus 1. For the second term, we will be left with 8 multiplied by 3x plus 1. In the coming step, we will open the parentheses so that we can add the like terms. So again, we write 3x plus 1 all power 4 here, 2x plus 1 all cubed here. Inside here we have 15 times 2x is 30x, 15 times 1 is 15, 8 times 3x is 24x, 8 times 1 is 8, and then we add the 24x to the 30x so that we get 54x. 15 we add it to 8 so that we get 23. And this will be the final answer for the derivative you are looking for.